Hi there, and welcome back. So, in the previous video, we went over the theory behind drawing Lewis structures of small molecules. Check out that video if you need a quick refresher. In this video, we will be doing some practice problems. So, for our first molecule, we have ethane. And the chemical formula for ethane is C2H6. So if you remember the 4 steps we went over in the last video, the first step is to determine the number of valence electrons for each atom. So go ahead and draw the Lewis structures for each atom. So we have 2 carbon atoms, and the Lewis structure for those looks like this. And then we have 6 hydrogen atoms. So draw those 6 Lewis structures. Right, each hydrogen has 1 electron. And so if you count up all the electrons, we have a total of 4, 8, and then 6 over here makes 14. So when we do our bookkeeping at the end, we have to account for 14 electrons. Then for step 2, we connect atoms that form more than 1 bond or multiple bonds. Since the 2 carbon atoms are the only atoms able to form multiple bonds, we connect these 2 together first. So draw these 2 carbons in a way in which they share a pair of electrons between them. So we take our 2 carbon atoms and then we make them share a pair of electrons between them, and then we fill out the rest of the Lewis structure. So since hydrogens only form 1 bond, we exclude them in this step. And now for step 3, we connect the hydrogen atoms to the connected atoms. So normally we connect the hydrogen atoms next to or with the atoms with more unpaired electrons first. However, in this case, since both carbon atoms have 3 unpaired electrons each, it doesn't matter which carbon you connect the hydrogens to first. So go ahead and place the 6 hydrogens on each carbon. So we have 1 hydrogen here, 1 hydrogen up here, 1 more over here, another hydrogen, our 5th hydrogen, and our final hydrogen right here. And so now for our final step, we pair any unpaired electrons so that each atom achieves an octet. Since we have no unpaired electrons, and since each atom has an octet already, or a duet in the case of hydrogen, we can skip step 4. As you can see, if we count up the electrons, we have a total of 14, which is how many we started with in the beginning. And now, for our shorthand, we draw single bonds with a single line and double bonds with a double line, triple bonds with triple lines, etc. Since this molecule only has single bonds, we will only use single lines. So, and you don't necessarily have to do this last step. It's just the conventional way of doing things. So if we bring our Lewis structure over here, we start with our carbons and then attach the hydrogens to each carbon with a single bond. And this will be our Lewis structure. This is the Lewis structure for ethane. And now for our next molecule, we have ethylene, whose chemical formula is C2H4. Ethylene. Once again, determine the number of valence electrons. That's step one. So once again, we have two carbon atoms that each have 4 electrons next to it, and then we have a total of 4 hydrogen atoms with 1 electron on each atom. So in total we have 4 plus 4, which is 8, plus another 4, which is 12. So we have a total of 12 electrons to account for. So I'm going to go ahead and write 12E right here, just so we can know how many electrons we're working with as a reminder. So for step 2, we connect the atoms that form multiple bonds. So join the 2 carbons together in a similar way as we did ethane in our first problem. So we take our 2 hydrogens, make them share a pair of electrons, and then we fill out the rest of the Lewis structure. Right. So next we connect the hydrogens. Again, since both carbons have an equal amount of unpaired electrons, we can just go ahead and stick the hydrogens on 1 carbon at a time. So we can bring our Lewis structure over here. We take our carbons, and now we can just connect our hydrogens to our carbons, 1 carbon at a time. 1 down here, and then 1 down here. Right. So finally, for our last step, we pair any unpaired electrons so that each atom achieves an octet. So in this case, we take the unpaired electron on each carbon and join them together so that the 2 carbons form a double bond. Right, so that means we just take these 2 carbons, this one right here and this one right here, and we bring them over so that the 2 carbon atoms form a double bond. So if we bring our Lewis structure over here, we have our 2 carbons, and instead of a single bond being between them, we will draw a double bond between them, or in other words, 4 electrons being shared amongst them. And then we just take our hydrogens once again, and then we draw them in like so. And now, as we can see, now we can see that each atom has an octet, or a duet in the case of hydrogen. And now, so this is our Lewis structure for ethylene. Again, we have 12 electrons in total. 4, 2, 4, 6, 8, 10, 12. So now we can just replace any single and double bonds with single and double lines respectively. So if we redraw our Lewis structure over here, if we take our 2 carbons and we can draw this double bond as a double line, and then we draw our hydrogens connected to our carbons with a single bond, which we will represent as a single line. So this is going to be our the shorthand for our Lewis structure. Now, if we wanted to go if we wanted to be a little more accurate, we can make the overall geometry of this molecule look like this. Right, we can make our molecule look like this, where the hydrogen molecules are at an angle. We'll go over why this is the case later on in the later videos to come, but for now, this should suffice. So this is going to be our final, more accurate representation of the Lewis structure of ethylene. And so now, for our third molecule and our third example, we have acetylene. Now, acetylene has the chemical formula of C2H2. So once again, we count the valence electrons. So acetylene is going to have 2 carbons in it. And since carbon is in group 4, it's going to have 4 valence electrons. So a total of 8 valence electrons for the carbons. And then for our 2 hydrogens, we have simply 2 electrons for a total of 10 electrons. In 10 valence electrons to account for in acetylene. So let's join the carbon atoms together, the only multiple bond forming atoms in acetylene. All right, so we take our 2 carbon atoms, we join them together in a way in which they share 2 electrons. And next we attach the hydrogens 1 carbon at a time. So we take our 2 hydrogens and then we connect them to the hydrogens. I'm sorry, the carbons. So now for our last step, since we have some leftover unpaired electrons on the 2 carbons, we're going to pair them up so that each carbon achieves its octet. So we take these 2 electrons on each carbon and then we join them together so that they'll form a triple bond. So if we redraw our Lewis structure, we have 6 electrons being shared between the carbons. So the pairing of those 4 electrons will form an extra 2 bonds, giving us a total of 3 bonds or a triple bond. So if we count the electrons, we have 10 in total, right? 2, 4, 6, 8, 10. So 10 electrons in total. So all the electrons are accounted for. Now we just replace our triple bonds and single bonds with triple and single lines for convenience sake. So we can draw our structure over here. We have H connected to our carbon, a triple bond, our carbon, and 1 more hydrogen. So that's going to be our Lewis structure for acetylene. So for our last example, I'm going to erase this. For our last example, we have CH3, CN, and this is acetonitrile. Now, for acetylnitrile, this its Lewis structure is going to be slightly different because of the presence of a nitrogen in its chemical formula. So, so first we are going to determine the number of valence electrons in acetylnitrile. So we have one carbon, three hydrogens, another carbon, and then one nitrogen. Since nitrogen is in group 5, it's going to have 5 electrons next to it for a total of 4 plus 3, which is 7, plus 4, which is 11, plus 5, which equals 16. So 16 electrons in total to account for. So now we connect the atoms that form more than one bond so that the two carbons and so that's going to be our two carbons and one nitrogen, right? So because these are the only atoms in acetylnitrile that form more than one bond. So we have one carbon, another carbon with 2 electrons shared between them. And then we have our nitrogen connected to our carbon with 2 electrons shared between them. And then we fill in the rest of the Lewis dot structure. So this is going to be our sort of our skeleton for acetylnitrile. So you might ask, why do we have to draw it this way? Why couldn't we draw it this way, for example? And that would be a good question, right? Because if Rule 2 says to connect the multiple bond forming atoms together, why does the order in which we do it matter? So we want to draw it the first way, this way, because of the condensed structure of acetylnitrile, right? In a condensed structure, groups of atoms are clustered together when possible. So that's the condensed structure, right? Which is this structure right here. The condensed structure suggests that there is a CH3 group connected to a carbon in the middle, which is connected to a nitrogen on the end. So it makes more sense to draw it this way as opposed to this way, right? Connecting the atoms this way makes more sense than this way based on the condensed structure, right? So let's get rid of this. So now we connect the hydrogens to our connected atoms here. So we connect them first to the atom with the most unbounded electrons or unbonded electrons. So that's going to be the leftmost carbon right here, since it has 3 unbonded electrons, whereas the other 2 atoms have only 2. So we take our 3 hydrogens and then we bond them to the carbon. And then we fill in the rest. And then Finally, for our final step, we pair any unpaired electrons so that each atom has an octet. Therefore, we pair the two unbonded electrons in the carbon with the two unbonded electrons in the nitrogen to form two more bonds, making 3 bonds in total between the nitrogen and the carbon, making it a triple bond. So if we draw our structure over here, we have our 2 carbons connected to each other, and then we have 3 electrons in between them, and then our 2 electrons on top of the nitrogen. So if we count up the electrons, we have 16 electrons in total, so everything adds up. So now let's draw our bond lines. So let's draw our bond lines down here. We have carbon, hydrogen, another carbon, a triple bond between nitrogen and carbon, and then 2 electrons up top, on top of the nitrogen. So this is going to be our Lewis structure for acetonitrile. So that's going to be it for this video. With that being said, thank you for watching and have a great day.